Hello class, welcome to our second lesson dealing with section 5.2, verifying trig identities. Make sure you have the paper that's a PDF online or that was given to you. All of those pieces should be helpful for you as you look at these questions. There's a few questions dealing with factoring I want to talk about first. So let's go ahead and get started with that. When you see factoring questions, there's probably two main types of factoring questions. One is like the one on the left that's difference of squares. Now remember, if it says to factor the expression, okay, you're not looking to change it with your identities. You're looking just to take it and factor it, much like x squared minus 1. So when it's difference of squares, remember it's the first thing square rooted and the second one square rooted and then plus and minus in between. That's going to show up fairly often, mainly because of the ideas of the conjugate when you multiply with the denominator later on. So that's something to keep in mind there. On the other ones that are factoring questions, my suggestion is you deal with the two ends. So 4 tangent squared has to be 2 times 2 or 4 times 1. Minus 3 has to be a 1 and a 3. And so just guess and check your way in order to figure out where it needs to be. If it's easier for you, you could make that 4x squared plus x minus 3. Figure out what it would be with just x's, and then plug in tangent of x instead of just x for the answer. This next question is a difference of squares. Here's what you'll notice. It's something squared minus something squared. And so it's still difference of squares. So it's first minus second times first plus second. And then you just kind of combine like terms and simplify. And the tangents cancel in this first one. The cotangents cancel in the second one. That's 2 times 2, which is 4. And tangent times cotangent or vice versa. Either way would be fine in order to find that answer. But that still is a difference of squares scenario. On this next one, you have cotangent to the fourth. Now this one's actually a little bit easier than some of the other ones you might see because everything's addition. Cotangent to the fourth has to be cotangent squared times itself, and then plus 2 has to be plus 2 times plus 1 because the middle term is positive 3. If that was a minus 3, they would both be minuses. And the issue is if they were both subtraction in this answer, let's take this last part. Cotangent squared, if it was minus 1, could be difference of squares again. So if there's a subtraction in the middle term, there's probably more things that you can do with it. Since it's addition of the middle term, there's not a whole lot that you can do. Obviously, the point of factoring at this point is maybe you can change this to something else or whatever you're looking at might make it easier to find. Okay, next one that I want to look at, it deals with sum and difference of cubes. You'll notice the formula here on the bottom. This is one version of the formula, but you could also just look one up online. Notice this plus minus thing. So if this is a plus, so is this one. But notice this symbol is flipped around. So if this is plus, this is minus. If this is minus, this is minus, this is plus. That's what those pieces are saying. Sine to the third plus cosine to the third. X and y in this case are just sine and cosine. Sine squared minus the two together, and then plus cosine squared. You're just going to have to make sure you realize which one is first and which part is plus and minus. And again, looking that up online and having an example written out might be helpful, or this note here at the bottom of the screen. The next questions are just verifying identities. I tried to pick a few that I thought are attainable and that you could follow along with. Anytime you have an identity, the goal is to start with one side to prove the other side. So for this first side, remember the goals are make things sines and cosines, distribute, things like that. So if I distribute sine into both of these things, I get sine times cosecant of theta, and then minus sine times sine is sine squared. From here, notice that sine and cosecant, they're reciprocals of each other. So any number times its reciprocal is going to be 1. And 1 minus sine squared is cosine squared, which is what I'm trying to prove. So they give you the ends. It's just like finding the middle ground in order to find that answer. So distribute, simplify, factor, okay, those type of things. Changing with the Pythagorean identities. All of those things could be useful here. The next question has tangent of negative theta over secant. Probably start with the more complicated side, which would be tangent of negative theta. This is one of the cases where you have to use on your paper the odd and even functions. Okay, they're also called the parity functions. You'll notice it says tangent of negative u equals negative tan u. Well, that's the same here, just with theta. So tangent of negative theta is negative tangent theta. Negative tangent theta over secant becomes times cosine because secant's reciprocal would be cosine on the top. And then make tangent sine over cosine. The cosines cancel, and you're left with negative sine. Notice here, though, that the rules still apply. I'm still just, if I'm stuck, I'm going to change things to sines and cosines. I'm going to use the quotient identity for tangent and then just simplify everything. The key to this question would be that odd-even function idea with tangent of negative theta becoming negative tangent theta. Okay, the next one is the difference of squares. So notice you have sine to the fourth minus cosine to the fourth. So sine squared minus cosine squared times sine squared plus cosine squared. Okay, that's the difference of squares technique. And then you say, well, what happened to the sine squared plus cosine squared? Well, sine squared plus cosine squared on your Pythagorean identities is 1. So it just kind of floats away and goes away because times 1 doesn't really do anything. And then the tricky part is you need everything to be sine squareds in your final answer. So you change cosine squared with your Pythagorean identities. Cosine squared would be 1 minus sine squared. Distribute the subtraction into the equation, and you'll end up with 2 sine squared minus 1. Okay, for this last one, this is definitely the trickiest. Here's the thing I would say to everyone to start with. If you see something plus or minus 1 on the bottom, you just got to multiply by the conjugate, which is the same term, just with the opposite sign. So for this one, it's secant squared minus 1. You'll multiply by secant squared plus 1. You can't split anything up here. You're better off working with the right side to start with because it has subtraction on the bottom. When you multiply by the conjugate, the top is just distributing, so cosine times secant plus cosine times 1. The bottom would be the Pythagorean identity, which is secant squared minus 1. Secant squared minus 1 is tangent squared, and all of a sudden, okay, now I've got what I need. You say, well, it's 1 plus cosine, shouldn't it be cosine plus 1? You could rewrite that using commutative property and still get the same answer. So the key is anytime there's a division of a lot of things, or a two pieces, excuse me, with a trig function plus or minus 1 or something like that, or vice versa, 1 minus the trig function, it's always going to be multiplied by the conjugate, Pythagorean identity, and hopefully some simplifying will work. Have a good day, everyone.